Hello everyone. In this video, I'm going to discuss the problem E, expected damage of the educational code forces round 95 div 2. So what this problem is all about, I can tell you the problem in the whiteboard. So we have a monster with a defense with a parameter D, and which denotes its strength, and we have a shield with two parameters A and B, and when we fight any monster with the shield with the parameter A comma B, then three situations can happen. One situation is our this second parameter is greater than the defense the parameter of the monster, and our first parameter is greater than 0. In that case, what will going to happen? Nothing will going to happen to the shield. And in the second case, when our A is greater than 0 but our second parameter is less than equal to the parameter of the monster, in this case we will going to receive no damage, but we will going to receive a drop of our A value by 1. So A will going to drop by 1. And what is the third condition? Third possible situation is like our A is equal to 0. In this case, we will gonna receive D damage from the monster. So for each shield, we have to find the expected damage that we're gonna receive if our monsters, we have n monsters that are arranged in some arbitrarily random manner, and each order is equally probable. So we have to find this like, since they are said in the question that this number is in the form of x by y, where this y will be co-prime with a large prime, that is 10 to the power 9 minus 7, and we have to find the answer for each shield as x y inverse mod this large prime. So we can say this large prime to be capital P as large prime. So now let us try to understand the problem with the help with general way, that what can be the way we will receive damage. So let us say we arrange the monsters. This is the way we arrange the monsters. So, and in this order, let us say the strength of the monster goes up. Let us say our D is increasing in this direction. That is, this monster has less D, this is having more D. So like we have sorted the strength of the D and the monsters. So there will be some threshold after which this D will go greater than equal to B. There might be some example in which D will never go beyond or greater than equal to B. But let us, for the sake of generality, assume that there will be one threshold after which D will be greater than equal to B. So let us call this earlier monsters which are having the strength less than B, less than the D. So in this case, D is greater less than B. So D is less than B. So see the monsters which have strength less than B, we can call those monsters as weak monsters, and the monsters which have strength greater than equal to weak, and we can call those monsters as strong monsters. So now each of the so now we need to understand, let us say we have this k weak monsters, and since we have total n monsters, so we have n minus k strong monsters. So now the n minus k monsters, if the value of our A is such that n minus k is less than A, so then it can never our A value will never go to 0, because even this n minus k will drop the value of A by n minus k, but this thing A minus n minus k will always be greater than 0, and the damage is only caused when our A is 0, A is equal to 0. So that's why we will not receive any damage. So in this case, if n minus k is less than A, if that situation will hold, so in that case the damage will be 0. But what about the other case? The other case is this: when our strong monsters are greater than equal to the parameter A. In this case, what can happen is both the monsters can cause the damage to the both monsters, weak and strong, can cause damage to our shield in the case when after the position when the A will go to 0, then both the monster can cause damage, D damage. So let us now consider first of all the strong monster, how and what is the probability that it will cause damage. So we have total n minus k positions of the strong monsters. So these are total n minus k positions. Among these n minus k positions, the first a positions will not cause any damage. So the first a positions will not cause any damage to the shield. So the remaining n minus k minus a positions will be equally probable to cause the damage. So the probability of the strong monster causing damage will be n minus k minus a by n minus k. What about the weak monsters now? The weak monsters and yeah, the weak monsters. Since the strong monsters are arranged in n minus k positions, so the weak monsters will be have this n minus k plus 1 positions, free positions to occupy. So n minus k plus 1 positions are there for the weak monsters to occupy. Like I can write here. So we have total n minus k plus 1 positions for the weak monster to occupy, and among these n minus k plus 1 weak positions, the first a positions will not cause any damage because this will only reduce the value of the a to 0. So the contribution or the probability of the weak monsters causing damage will be n minus k plus 1 minus a by n minus k plus 1. That is this part n minus k plus 1 by the total this part. So n minus k plus 1. So this is the contribution of the damage by the weak monsters. So we're going to calculate the we have to calculate the answer for this y. This is x by y. We have to calculate the answer x y inverse. We have to, if this is x and this is y, so we have to find the answer of like this x y inverse mod that b prime. And using the famous Euler's theorem, like I can show you the theorem. Using the theorem of Euler's theorem, we know that there is a special case which is called Fermat's little theorem. So whenever we have to find A inverse mod m, so this is actually equal to A power m minus 2. So in this we will going to use this fact to solve this problem also. And so let us look at the code to understand it a little bit better. So we have this input and we have this input of the strength of the monsters. We will want to sort the strength, and then we will also have a prefix sum because the things that we have calculated are the probabilities, but we have to calculate the expectation. So we will have to also multiply the strength of the weak and the strong monsters respectively, the total strength to calculate the expected damage caused by both of them. So the prefix sum will help us to calculate those contribution of the strong and the weak monsters. So prefix sum we have calculated, and after that we have calculated that what are the number of the weak monsters, and then what we have calculated this denominator n minus k minus a, and n minus this numerator that is n minus k minus a, and also n minus k minus a plus 1. So we multiply the numerator by the denominator mod. When we say, I have told you that just that whenever we have to find y inverse mod m, so what we're going to do, we just take the power of y with the mod minus 2. Here mod is capital P, which is a big prime, and we multiply that with the total strength of the of the strong monster. And for the weak monsters, what we're going to do, we this is our numerator, that is n minus k minus a plus 1, and then we multiply this with the power of p minus 2 and minus k plus 1, and then we also multiply this with the total strength of the weak monsters. So in this way we can just calculate the answer. So I hope you understand some part of it, if not all. So with that note, I terminate now.